Thank you very much for the invitation to Virtual Caltech, currently Scientia. Today I will be talking about cable cars, a good alternative for transportation. First, few things about me. I'm Dex Euromat, in real life known also as Dominik Undak. I was born and I live in Poland. I graduated from AGI Science and Technology University in Krakow, Poland in 2010-11 with title Master of Engineering. I am currently working as a quality analyst in one of the software houses. I've started my second life journey in 2008 under a different name. Current account is from 2010. Over the years I've been participating in educational projects such as Academia Electronica, non-institutional part of Jagiellonian University in Krakow, Poland, Atlantis Language Learning Community Virtual Library, then Virtual Worlds Educational Consortium, mainly on information duties, and also fireside chat with Polish. Also have my own project in Second Life, Poland History House. It's about history of Poland and inventors and inventions launched in 2019. To start, we need to understand that different countries use different terms for the category. However, all of these terms are interchangeable. So cable equals line equals rope. Interesting fact is that the names change with the continent you are on. Cable cars is mainly used in America. Line railways is used mainly in Europe and Africa, and ropeways is used mainly in Asia and Australia. As I have EU origin, the line railways is the main terms used. However, the main element requires a clear distinction for this presentation. Cable is a multi-purpose lines, in example power and support usually found in chairlifts. Line, single-purpose line, other than support, in example power, towing, hanger. Rope, this is a single-line purpose lines only for supporting, they are usually thicker, an example for B-cable or three-cable solutions. Cables for usage in cable cars have similar structure as their electrical counterparts. They are made out of single steel wires weaved together, sometimes around central wire, to make the line stronger. Usually there is no additional layer of coating, only the factory coating as represented on figure 1. Interesting fact. For the looped constructions, the power line wires are weaved together so tight that you hardly can see the connection. Such weaved connections can be up to 50 cm long. Now you may ask why no melting or welding wires together. Simply because the friction between weaved wires is much stronger than these connections and does not break easily. The best reference is the two phone books weaved together that Mythbusters tried to uncouple in their season 5, episode 7. Okay, we described the main element, the cable, but what about other elements? On this slide we have shown following. Trolley, a set of wheels or rollers that rides on the rope. There can be 1, 2, 4, or even more sets for one trolley, depending on the size of the car, hanger, and amount of the ropes. Hanger is a connection between car and grip and/or trolley. Usually hangers are L-shaped, so the car is balanced in the right way. Grip, a connection between hanger and power line. Grips are a kind of big pliers that are manually applied and adjusted or automatically via special mechanisms on the station. Support ropes, lines on which car virtually rides. Power line, lines that give the car propulsion. Tower, non-active tensioning and direction change line supports. Usually there are minimum 3 on the way. Some solutions use less or none. Next we have tow line, an emergency line used in shuttle constructions allowing crew to get passengers safely to the nearest station. Some constructions with a middle station may use it as a power line. Stations, the endpoints of the support and power lines with active tensioning systems like weights, drums, or actuators, usually one motorized. Bull wheel, main power line looping, tensioning, and their propulsion system. Line velocity, speed of moving cars, usually in meters per second. Capacity, amount of people the construction can hold per 1 hour. When you get to the station, you might have the chance to see these numbers, as they are often printed on the bull wheel supports. However, these are maximum values, and during normal operations the line velocity is always a bit lower for safety reasons. Interval, brake distance between two cars, in meters or seconds. Efficiency, percentage of capacity at given time. Chairlift car, open seat car. Single, double, quad, six-pack or ram charger. This is the amount of chairs in a single row for one chairlift car. In other words, 1, 2, 4, 6 or 8 people per one car. Gondola is an enclosed car with or without seats. Gondolas can have capacity from 4 to even 200 people per one car per ride, depending on the selection. Fixed, detachable, gravitational, gripping way to the power line. As we mentioned earlier for grips, fixed equals manual, detachable by mechanisms. But there is one manually detachable system that solely uses gravity and friction. This one is used in aero-cable cars that use only gravity as propulsion. Stations only have brakes and manual cranks to start the bull wheel, but no motors at all. One of such systems can be found in United Kingdom, and is mentioned in a documentary made by Tom Scott. It hauls the clay from the quarry to the bricks plant below. What is interesting is that there is no other more efficient way of doing that. Even the computer program that calculates the data couldn't suggest any other mode of transportation. Use of cable cars is well known from ancient times. Interestingly, we still use such constructions, but more for fun than transporting goods. We call these zip lines. In Europe also called tie roller, or, like in Poland, Tyrolka. The name came from the Austria-Italy Alpine region Tyrol, where there were many of such constructions used during the World Wars. Fun fact: Tyroler or Tyrolka is a mashup of two words, Tyrol and English roller, Polish rolka, and depending on the context may mean a boy or a girl from Tyrol. As shown in the figure 2, for making such thing we need two ridges, usually one higher than the other, rope mounting construction on each end, the stations, a car, basket, platform or harness suspended on hanger, usually other lines, by hook or snatch block as the trolley. And finally a pulling line attached to the trolley that allows us to get to a higher station. Zip lines are the basic line bridges, and in ancient times they were used as temporary connections until a more stable bridge got established. There are interestingly also flat zipline connections on the same elevation, but these require the pulling line to be traversed through the car. So the passenger can pull it either way, usually via some sort of pulley, with a crank or by hand. Here are the examples of these constructions. Left one is the Slovenian Cicka, manual zipline traversing over River Savo. Unfortunately, such constructions usually are not maintained very well, and that one eventually got closed. However, you may find several constructions around the world that are still in operation and are maintained properly by the owners. You can hear more about it in another Tom Scott video. As shown on the right example, from Łódź, city in Poland, in the Manufacture Shopping and Cultural Center, modern ziplines use mainly one cable, on which trolley rides. However, for the safety reasons, in some attractions there is also at least one more cable that can have few purposes: grounding, braking system support, safety line in case of riding line breaks. The longest zipline in the world is in the United Arab Emirates, almost 2.8 kilometers. Poland currently has the longest one in Central Eastern Europe, 0.45 kilometers. The steepest zipline, with about 56% incline, is in Nepal with 610 meters drop. Most known in Europe is the Planica ski jump, with 202 meters drop and around 500 meters long. You can easily find this in Google. There's lots of videos from those attractions. Alright, we talked about the first constructions and that they survived till today. But what about modern ropeways? We had to wait till the 17th century, when an Italian engineer from Venice, Faust Verezio, made plans for such thing. However, the first known built loop system model was developed by Dutchman Adam Wype. Interesting fact is that his full-scale solution was adapted in the free city of Gdańsk, Poland, to create transport for building materials for extending the pier for more ships over the port canal. Unfortunately, for more sophisticated constructions, we had to wait till the 19th century. First inclined tram started around 1800 in North Wales. From 1840 to 1848, a cable railway was hauling goods between London City and the docks. Unfortunately, this construction got redacted and replaced by steam engines due to safety issues. The funiculars were introduced in 1862. Interesting fact is that the area funiculi was inspired by funicular. San Francisco Cable Tram Railway began operation in 1873. In 1881, first non-America or Europe cable railway started in New Zealand, Dunedin. In 1908, there were two new inventions introduced: gondola and surface ski lifts. World War I gave us the quick evolution of single-line cable cars. In 1924, a seasonal winter sleeve funicular was established in Switzerland. In the 1930s, we got handle, nutcracker, and J-bar for surface ski lifts. Also, the first chairlifts in Sun Valley Ski Resort in Idaho got introduced. In the 1940s, surface ski lifts started to use T-bars. 1966-67 came with detachable gondola system, and in 1972 detachable chairs got introduced. The first funicle system was introduced in 1990. The development is still going on. Just a few years back, an 8-seat detachable chair got introduced. As mentioned in the definition section, Figure 3 shows the usual minimum setup for ski lift, chairlift, and gondola systems. These are mostly single cable solutions, as the cable is the power line and also the support rope. Two stations, usually one with propulsion and 3 towers between. There are mainly two constructions. Open bull wheel, with usually lower station motorized. These are solely for fixed grips and are used for small gondolas, 4 people max, or chairs or surface lifts. Fixed gripping has one big issue as for the maintenance. Chairs and gondolas have to stay on the line for the whole season, no matter how harsh the weather can be. Taking off and reattaching them back takes a lot of work. Enclosed bull wheel constructions have additional loops for safe unload and load zones, as shown on Figure 4. These constructions are often used for detachable grip, chairlift, or gondola systems. Nowadays, you may find hybrid solutions that involve both chairs and gondolas. However, it has to be done in the following way: chair, gondola, chair, where the balance of the amount of people is gondola equals double chair. So when there is a light rain and nobody uses the chairs, the tension of the line is still balanced. There are also constructions with gondolas which use 3 cars in a row and then large intervals to the next seats. So how does the detachable system work then? The grip pliers on the line is using a spring and lever that extends out of the grip point. Both lever and grip point have additional rollers. Depending on the system used, the lever can have 2 or 3 positions. The 3-position lever, red arrow on the right lower picture, can indicate which direction the car is going. Figure 5 represents the system for 2-position levers. The car comes in via a set of sway dampeners, also shown in the right bottom picture. Then it is being detached from the cable by compression spring tension on the lever via the red bar. Now the car is rolling on the additional track, while cable is moved slightly down to bull wheel and maintains constant speed. Above the bull wheel, there is a special reduction gearbox that powers the passenger loop traction system. This loop usually slows down the car to 0.5 meters per second to allow safe unloading and loading. You can physically feel the change of speed as the braking and acceleration is quite fast. Traction systems are usually wheels with tires connected to each other by reduction gears with chains or belts, from the main gearbox by usually 2 or 3 driveshafts. Some solutions use chains instead of wheels, in example double gripper, or with the wheels, horizontal chain with mounted hooks to maintain speed, where the wheels are not mounted on the curve of the loop, like shown on the bottom left picture. When a station has a storage for cars or maintenance route or next line, bottom center picture, the loop can be extended with a connection where sliding the car to the next point can be manual or automatic. That also means the cars can be taken off the line when the working hours are done or maintenance is required. As mentioned before, the line velocity is usually lower during normal operations due to safety. But the list of safety measures is much longer than that. Constant communication between lower and upper station is required, so even the ski lifts have at least 2 operators that communicate via radio and or hand signals. Each set of rollers on towers has special profile that allows smooth transition. Towers without support rope rollers have specially shaped tracks in which rope lies. Sheaves on both sides of the roller to prevent line slipping from its route. Brittle bars, a mechanical brake with tensor that triggers emergency stop. In case the sway from the wind is too high and the line moves further than the brittle bar, there are 2 hangers, cable catchers, that hold the line on the tower. Weather is a key information in operation, so there are sets of condition sensors on the stations and at least one on the towers. Grounding is provided by additional line that goes from station to station in the middle and overhead. Stations are often equipped with many sensors that measure line slippage on the bull wheel, line position, force of tensioning, grip correctness, etc. If the electric power is somehow gone, stations usually have additional power generators and or diesel engines to help people get off. Some ski resorts use additional moving pavements, wide conveyor belts, to ease transition from standing position to sitting when using chairs. Gondolas have ski hangers on doors or sides. Each station has a tensioning and braking system. Also, each day before allowing people in, there are tests and checks conducted to be sure everything is working as it should, which also include short breaks in operation during normal working hours for maintenance. Each season, each construction requires a series of tests that include capacity tests, which means sandbag rides, and cable inspections, both visual and non-destructive fatigue tests. I have mentioned ski lift solutions a few times. Let me give you some examples. Left picture shows a ponytail right uphill. Right picture shows the nutcracker harness with the grip. In both situations, you use hands to keep the grip on the line and to drop it on the upper station. The difference is the height of the line. Ponytail around stomach, nutcracker around waist, crotch. T-bars are for 1 or 2 people at once, the left picture. J-bars are for single person at once, center picture. And there's also magic carpets for children in ski schools, right picture. Now, does more lines equal higher capacity but also complexity? That depends on the location, plant capacity, usual weather conditions, etc. You may need additional rollers for grips and power tow lines on towers. You may need additional hangers that are placed on the support ropes between towers to keep the power tow line on its route and keep it from hanging too low. You may need an extra grip point on the hanger. You may need longer roller drive shafts that will ride in and on the tracks on towers. Detachable systems can use gondola cars with max capacity of 30 big cable and 35 people 3 cable. Fixed grip shuttle systems can use gondola cars with capacity up to 200 people. While more stable during harsh weather conditions, higher capacities took way longer to evacuate in case of emergency and then to repair damages. The usual B and 3 cable solutions are shown on figures 6 to 9. When aerial transport requires more stability with more car capacity than standard solution, there are two different approaches that provide these. Funitor, upper image, and Funitel, lower image. Funitor is a 3 cable solution where the power cable is looped through the car trolley by a set of 2 smaller bull wheels. The top loop acts as a power line, lower as a tow line. There are usually 2 vertical bull wheels on the station on a single drive shaft for each track. Funitel, on the other hand, can use 2 separate or 1 looped cable. It also has 1 drive shaft, but the bull wheels can be on top of each other or separated at the same level. While Funitor use gravity and the grip and self-tensioning on the car, Funitel uses only detachable grips. The max capacity per one Funitel car is around 15 or 30 people, depending on gondola manufacturer and placement, and for Funitor it is 60 plus passengers per car. Let's move to line railways that use train tracks, cable trams, and funiculars. While both have similar concepts of pulling cars to different points of the city by a cable between a set of rail tracks, those constructions differ a lot from each other. The table on the slide shows key differences. Trams are often merged within the city streets, with tracks and special gaps for the power line. Because they use their own brakes, the power line is simply detached before the stop and then reattached. Applying grip is gradual to avoid sudden jarring the car and therefore creating discomfort for passengers. Because of that, slippage, the condition of the grip pliers lowers drastically, and they have to be replaced each 3 to 5 days. Line length per one route can be even 10 kilometers, and the maximum incline is 30%, 16.7 degrees. So there is no need to change the angle of the platform. There can be several cars using the line at the same time, and as the stresses on the power line can be easily balanced at power stations. Funiculars, on the other hand, are designed solely to traverse hills with higher inclines, up to 114%, so 47.7 degrees. Here the power line is in constant stress, and the weight is balanced by the other car. Because of that, the maximum line length is 2.5 kilometers, and the funicular only does shuttle operations, with a minimum interval of 15 minutes. The advantage of balanced weights is that you need minimum power applied by the top station to run such a solution. There are also fully gravity-powered funiculars, where there are no motors and only the weight of water in the tank of each car makes it run. Here are the cable tram examples from San Francisco. And here are the examples of funiculars. Left picture shows the water weight gravitational funicular in England, and the right one shows Gubałówka mountain funicular in Zakopane, Poland. As shown on figure 12, funiculars can use separate or same tracks with turnout sections usually in the middle. The turnout allows the middle station to be built if necessary. Here is a link to experience of the other Polish funicular in Krynica-Zdrój, which was established in 1947. You may ask, can this haul larger loads? The answer is yes. Here is an example. Sometimes making water locks on the river is too expensive and may make the experience worse. That is why at some rivers, canals, you may encounter boat funiculars, like the one in pictures. This one is one of many in the Elbląg-Ostróda Canal in Poland, and these are considered as technical monuments, but still working. Funiculars can also be used to transport cars and trams when required. Interesting facts. The table chair system was introduced by a Polish inventor and his company, Poma, established in France. They are researching and creating new ways of aerial transport to this day. Name of the company are 4 first letters of his surname, Pomagalski, which means the helping man. Cable cars can turn on the line, either on middle stations, left picture, or special turning tower sections on the right picture. There are even solutions that can have 2 lines in Y shape, with a single lower station. That's for ski lift, and very rare. Cable cars can be used by people with disabilities. The car might be stopped during the ride for them to enter or leave. So please don't be mad at them if you spend some time waiting to proceed, hanging over the zoo lion's space. What is more interesting is that you are riding a funicular type of transportation every single day. Because funicular is considered as an incline elevator. But not all incline elevators can be funiculars. Elevators usually use concrete and steel blocks as counterweight. Only few in the world actually use a second car in the other shaft. And they operate on demand. Is it possible to connect both? Yes. The Ascensore Castello di Alberti's Montegretto in Genoa does this trick. Please see another thumbscreen video. Before going further, I would like to mention my sources. Wikipedia, both English and Polish, YouTube, Polish Line Railways, Journal of Public Transportation, Volume 19, Issue 1, January 2016, The Gondola Project, Ostruder Elbląg Seafaring, Silesian Park, also on experiences. Mentioned Journal of Public Transportation is one of the few sources for the next aspect I'll be talking about. Cable cars versus climate impact. As you can see, the data is available only via articles in journals or studies published by aerial transport enthusiasts. Obtaining the data is a tedious process, as the information may be accessed only after the solution was created. Some developers were not even conducting climate impact, carbon footprint studies till the latest changes in regulations. In example, the Polish line railways. Here are the links. However, the information they provided can be summarized like this. Very low carbon emissions, around 0.01% per passenger per kilometer. In a study for one route in Italy, prognosed 300,000 passengers during a year would generate only around 500 metric tons of CO2, compared to other modes of transport as shown on figure 13. Cable cars work mainly with electricity, and emissions are from backup systems and passengers. There are minimal and localized pollution. Backup generators may produce some, also passengers, but the camera surveillance makes littering on cable car routes quite hard, sometimes even impossible. There is no extensive changes to the existing environment. It may require cutting and trimming trees, but developers have to agree to sustainability plan and pay for planting new ones. Exception from funiculars is that you have to do alterations to the route's terrain by placing tracks. Low wind disturbances. Most stations are open with as low as possible wide wind resistance. Pylons for towers are most times single columns or mesh constructions, so wind can easily move through. Low view disturbance. They might disturb the view when newly built, but after some time the locals will get used to them. Only tourists might complain that the lines do not look good on the photographs. Sound pollution is minimal. Only when you are on the station or under the tower you may hear something. Aerial cable cars are usually very silent. Funiculars may have more sounds as the car is riding on tracks, but usually you hardly notice that. Now, is the cable car solution really a good transport alternative? The answer is 1. It depends on the place. When connecting two cables to two cities, better use trains, trams, and or buses. When connecting two landmarks with the same area, an example in park, it is a good alternative for bus or walking between them. When connecting two landmarks with the same city, different areas, it is a good alternative for buses during rush hours, however not really for trams or metro. Connecting two landmarks on different elevation, it is a good alternative, however here all things get to the cost in the long run. The disadvantage of this kind of transport are the emergency costs, as they often require specialized equipment that may include use of helicopters. Speaking of costs, here is a solution comparison table. As you can see, max speed and capacities of solutions increase, but also the initial costs. However, the operational and maintenance costs are relatively small compared to other modes of transport. For the city areas, Genoa was already mentioned as it's quite a vertical city. But what about more flat cities, the ones with low hills? Such solutions are considered as the lowland cable cars. And here I'm presenting to you a solution made for Provincial Park of Culture and Leisure in Chorzów, Poland. However, the park got the name shortened a few years back to Silesian Park. Many people still use the original one from the 60s. Originally there was a single cable double-seater chairlift, top left picture. After many years it got turned down, and in recent years it is being re-established with the new hybrid system, gondolas and chairs, top right picture. This connects three key points in the park. Route 1, Silesian Stadium with Silesian Amusement Park. Route 2, Silesian Amusement Park with Silesian Planetarium. And Route 3, Silesian Planetarium with Silesian Stadium. This is currently under construction. Similarly, in Yokohama city in Japan, you can take a ride over the river. Also, some Disney parks use chairlifts for moving people between attractions. Such constructions often get their own shorter names for better recognition, like in Silesian Park, Elka, or Wrocław Polytechnic, Polinka. Thank you. Now it's time for questions and answers. Yes, gondola can hold up to 200 people, depending on used solution. I believe in New York there is a aerial tram over the river that one gondola can hold around 100 people. Power usage-wise, is it more effective to use cable cars or have the motors on the cars themselves and have electric lines? Well, that also depends on the situation and the placement, but usually there is the motors are on at the stations. So, for example, in the Buenos Aires cable car, you can see there is additional lines with with power from the ground to the upper station. Yeah, there's different approaches. The Salesian Park mentioned in this presentation also in recent months also tried an AI-driven bus. However, I didn't had have the opportunity to try it. Currently, I know there are some chairlifts being made, and all the current ones, and also that is being current ones are being modernized. So yeah, they are wheelchair friendly. Even chairlifts can even on chairlifts you can easily hold a passenger with a disability. You just need to stop the car and place the person on the chair, and after that you send the wheelchair on a special platform. In some solutions, there are also bike hangers on the chairs, so you can travel uphill with your bike. Well, we will see. You're welcome. Yeah, the space elevator should be a detachable one solution, as the cable should be fixed on the ground and in space. Uh, without support, well, without support, it's about 2.5 kilometers max. Oh, of course, on Earth, because the line is, even if not very thick, it is still quite heavy and can hang a lot. You can see, for example, the Rio de Janeiro cable car, where there is no supports on between two sections, between two stations, and you can see that the line hangs quite much. Yep. Gold is not very good. Of course, longer periods of cold. A lot of maintenance have to be. Sure, you can visit it anytime. Yeah, metal flexibility in different temperatures is also a key here in this application on the moon.